In this video, we'll be taking a look at the physics component of robotBuilder. Now, if you're interested in following along, I'm using a project file called completedtetrixnophysics.rbproj. So with that said, let's get started. Basically, we're at a point where we're finished building our robot, and we want to answer the question, what would happen to this model if it were subjected to the physical forces of real life? In other words, what would happen to this robot if friction acted on it, gravity acted on it, we changed its mass? Well, to answer those kinds of questions, we're going to have to enable physics. And so to start, let's click on the render menu up here and enable physics. And when we do this, the first thing we notice is that some of the objects in this model have changed color, as is the case with this Omni wheel. This is basically robotBuilder's way of telling us that there's something special about this object. In this particular case, it has a collider assigned to it. As we flesh out our model and assign other responsibilities to other parts, we'll see this model change color and shape in a lot of different kinds of ways. The second thing we need to reacquaint ourselves with is the simulator controls up here on the toolbar. If I hit play right now, I start the simulator and you'll see that nothing terribly interesting is happening. That's because I haven't assigned any physical components yet to my model pieces. I can stop the simulator and reset its position if it had changed position. So let's now take a look at how we would go about assigning a role to a component in this model and giving it physical properties. For example, right now we're on the left side of this robot. If I expand my hierarchy view here and take a look here at the left channel, which is highlighted, and scroll down, I can find the motor wheel assembly, and I have my rotational object tool button selected so I can find it, but I can also use the move object button. I'm going to click on this wheel and I'm going to zoom in so I can see it. Right click on the wheel and it opens up this context menu. Hit add and give it a rigid body. The physics engine only interacts with model geometry that has a rigid body assigned to it. So if I want this wheel to be affected by the simulator, I'm going to have to assign it a rigid body. So I'll click on it. When I do that, I get this orange cube, which again is a visual cue that there's something special about this wheel. If I go up into the properties window, I see its name here, wheel 76 millimeter, 3 inches left. We know we're familiar at this point with the transform menu. But I now have this rigid body menu, which I didn't have before. If I expand that, I get a whole whack of options for things I can do. For example, I can change this wheel's center of mass. The default is for the center of mass to be at the center of the object, 0, 0, and 0. But I could give it a very specific value. For example, if I wanted to specify a fractional value for the center of mass and give this thing an offset, I could key that in and hit enter. When I do so, the orange cube shifts up. I could also use this increment and decrement arrows here to the right, and if I do that, I've put it way up here. So the center of mass for this wheel is way up here, which isn't correct at all. So I'm going to put it down to 0, hit enter. I can determine whether this object is kinematic or not. If an object is kinematic, it won't be affected by outside forces in the model. So for example, if this wheel were to collide with another object, if it's kinematic, it won't be affected by that collision. And you may or may not want to choose that option depending on what you're trying to model. The default is for it to be turned off, and I would recommend that you keep it that way because it might create some headaches for you down the road when you're trying to do some testing. I can assign a specific value for the mass of this wheel, right? So the heavier an object is, the laws of physics are going to treat it differently. If this wheel weighs 100 pounds, or I key in a value of 1,000 for it, it's going to react very differently than if its value is only 1. Generally speaking, in a collision, heavier objects will push lighter objects out of their way. When we think about the rules of friction, it's going to take a lot more energy to move an object with a higher mass. So here in this text box for mass, I can key in very specific values for what I want the object's mass to be. Then of course there's things here for angular velocity and linear velocity, which we may or may not be interested in. The last thing I want to take a peek at here is use gravity. If I uncheck this box, this wheel will not be affected by gravity, which means that if the rest of the model was subjected from gravity, the rest of the model would separate from this wheel, and this wheel would remain stationary. I'm going to recheck it, and I'm going to close this rigid body. Let's go through the exercise now of assigning rigid bodies to all of these wheels. So I've assigned it to this wheel. I'm going to take a look here at the right channel, and I'm going to assign a rigid body to the remaining wheels here. So I'll assign a rigid body here. If I expand the channel, I get an omni wheel. I will assign a rigid body because I want all of my wheels to be affected by the physics engine. And I'm just going to go back here into the left channel because I don't think I've assigned a rigid body to that omni wheel. Let's take a peek. Add rigid body. Okay, so now all of my wheels have rigid bodies. The next question we have to answer is what happens to these wheels when they collide and interact with each other? Well, to deal with that, we'll have to assign colliders to each of these objects. When an object is assigned a collider, it makes them it gives us a way of describing those kinds of actions. So for example, if I click here on my left channel and I find my wheel here, I can assign a collider to it. And it will ask me for the shape of the collider. The shape of the collider is basically the surface area that will trigger the collider. So generally speaking, you'll want your surface area to be very closely fitted to the actual object. For example, I could assign a box collider if I wanted to this wheel. I see this green area highlight, and it doesn't really make a lot of sense, right? Because this boxed in green area is the area that is eligible to make contact with other objects, and that is not closely fitted at all to our actual wheel. So I'm going to remove that collider. I'm going to right click, add, and assign it a sphere collider. And again, we notice that the space that's been assigned to it is pretty generous, so we're going to go into the properties, and here under radius I'm going to give it a different value, a value of 0.05, and that's a little too big still, so we'll give it a value of 0.03. And when we get a little closer to this wheel, it's hard to tell because the rigid body is covering it, but that seems to be a little more closely fit. So let's now go through the exercise of assigning colliders to these other items. Let's take a fixed sphere collider, and I will give it a radius of 0.04. And you can see at this point that by having that render menu open, it's a lot easier to determine what things are being affected. So I don't have to spend a lot of time checking each of these objects in my hierarchy view for what objects are being affected by the physics engine. I'm just going to change my view, and you'll find that over time you'll become quite proficient at manipulating views. I'm going to add a collider, sphere collider, 0.05. And my last wheel over here, I'm going to also add a sphere collider, and I will change its value. Okay, so all of our wheels on this robot have been assigned a rigid body, which makes them eligible to be affected by the simulator, and they've been assigned a collider, which gives very specific rules for what will happen when these objects interact with another object in our model space. Very quickly, you'll notice that these objects now have a third property. It may be collapsed in your view, so you can click on it, which is the collider view. And again, these are all variables that can be manipulated. So for example, there's the center of this collider. Generally speaking, you'll want to keep it at 0, 0, and 0 so that it's closely mapped to the surface of the actual object. Then there's this question of physics material, which basically states that when this object collides with another object, how is it going to react? Well, in this particular case, I've decided that the wheel will react as if it's made out of wood. So I can see that values for friction, the dynamic friction, which is the friction that is encountered when this wheel rolls, the static friction, its bounciness, these values are all predetermined by this preset here. I can change the physics material of this wheel so that it behaves as if it were made out of rubber. And again, the friction values and bounciness change. I can make this wheel react as if it were made out of a bouncy substance. Here, the values have changed and the calculations for determining friction and bounce have both changed. I'm going to keep my wheel as if it were made out of wood, but you can experiment with those presets if you find that a more convenient way of working. Last thing I'm going to show you here is the trigger. The trigger functionality has not yet been assigned in this beta release, but going forward, what we're hoping to do is that instead of having this in a collision, instead of this object just interacting with a physical space, we can assign an event handler. So there might be custom script or custom code that we might want to have executed when this object collides with another piece of model geometry. If I check this box, it will enable that, but right now this functionality is closed during the beta test. If I hit play right now and zoom out, we can see how the changes we've made will affect the model. I'm just going to start the simulator, and we notice that these objects all fall. But of course the chassis of the robot has not fallen because we haven't assigned any physical properties to it yet. I'm going to stop and reset it. I'm now going to go to the effort of giving the chassis a rigid body. And I'm going to give the chassis a collider if it doesn't already have one. I'm going to give it a box collider. The box collider is pretty generous. You may have to play with this here to give it the value that you want. So for example, the size is set at 0.1. Let's just see here. Whoops. And this is purely a process of trial and error. So if it takes you a little while to arrive at your desired destination, that's okay. But right now, basically, I have my model rigged. And now if I hit play, the model falls, the wheels snap off, and you have to ask yourself, well, why did the wheels fall off? Because we haven't defined the relationship between the wheels and the model. We have to physically connect our wheels to our model. To do that, we need to open up a constraint, which is a window we haven't seen before. If I click on this view menu and click on constraint view, I get yet another window. It too is also dockable if I so choose. I need to click on environment and I need to add a constraint. It's going to ask you what kind of constraint. I want to create a fixed constraint. And in my properties window here, I get a bunch of other options. So the constraint basically is a way of connecting two pieces of model geometry. I'm going to specify that my main body here is my chassis, and what's the secondary body? What's the object that is connected to here? Well, it's going to be one of my omni wheels. And there's other options here like the brake force and torque. Basically, this is the amount of force that if this is exceeded during torque, our constraint will snap off. So torque deals with twisting a model object. Force, if I were to throw this thing, faster than 3.4 whatever, the hinge or whatever's connecting my wheels to my chassis would break off. So that's what that's all about. I'm going to specify a couple of constraints here. I can see now in my constraint view that I have a chassis and an omni wheel assembly. I'm going to add 3 other constraints. So I'll add another fixed constraint. I'll add a 3rd fixed constraint and a 4th fixed constraint for all of my wheels. And I'm just going to I'm just going to populate this data. This is where having meaningful names for all of your objects is useful. So in each of these cases, it might be hard to tell which wheel I've already parented. You may want to call your wheels left, right, forwards, or backwards, or give them a meaningful name so that it becomes easier to create these kinds of relationships. I made a mistake here in my parenting, so I'm just going to re-add this, add a fixed constraint, and I'm going to add a fixed constraint. And again, I'll want to specify my chassis, my right wheel in this particular instance, and my chassis, and my left wheel. Now, when I hit play, my object falls as one piece of geometry. That wasn't so great because I've placed my object along the edge, so I'm just going to move it. Whoops. And let's turn off the render. So when I hit play now, my object falls as one piece of geometry. So that's the physics engine for you. In later videos, we'll take a look at how to assign device controls to this robot and how to create a simulated environment for which to conduct our testing.